Hello, my name is Adam. In this video series, we are going to learn how to make Super Mario Bros. In Unity. Super Mario Bros. Is a platformer game developed and published by Nintendo for the NES game console. Players control Mario as they traverse the Mushroom Kingdom to rescue Princess Peach from Bowser. They traverse side-scrolling stages while avoiding hazards such as enemies and pits with the aid of power-ups such as the Super Mushroom, Fire Flower, and Starman. I've decided to break this tutorial into multiple videos because of the complexity of the game, and I really want to implement as many features as possible since it's such an iconic game. This first video will focus on scene setup, sprites, prefabs, and level design. The entire playlist is available in the description of the video, along with each individual video in the series. Subscribe to the channel to stay up to date with my latest tutorials as well as the upcoming videos in this series. Thank you. Enjoy. Let's begin by creating a new project using the Unity Hub. In the top right corner, we can click the New Project button. At the very top center here, we can choose which version of Unity we want to use depending on which versions you have installed. So for this tutorial, I'll be using 2021.3, which just became the new long-term support version as of a few days ago. However, it won't really matter which version you use because we'll be using all very common components that have existed for quite a while. So feel free to use whichever. We will use the 2D template here since this is going to be a 2D game. This will install all the various 2D packages. And finally, you can name your project whatever you'd like and choose where you'd like to save it. Go ahead and click the Create Project button, and this might take a few minutes to initialize, so we'll pick it up as soon as it's finished. All right, let's first import some sprites that we're going to use throughout the entire project. If you want to use the exact same sprites that I'll be using, you can download them from the GitHub project. There's a link in the description of the video. If you do open up that link, you should see the GitHub repository. From here, you can go to code, download zip, or if you are familiar with Git, of course, you can use Git commands to clone this repo. Let's go ahead and extract this folder that is downloaded. And within here, we should find our sprites in the assets folder and then sprites. There's all these PNG files we have here. There's also all these meta files, but those you can ignore because those are generated by Unity automatically once you import any kind of image in your project. So let's take just the PNGs and let's just drag these into the project panel here at the bottom. This will import all of these assets, and I'm gonna also organize them into their own folder here. So let's call this sprites and move all those in there. So for any image, once it's imported in Unity, you can change some of the import settings on that image. So we need to change some of these settings. I'm gonna change them for all of them. So select all of them there. And most importantly here is the pixels per unit. I'm going to set this to 16. All of these images were designed at 16 pixels per unit. So what that means is for every 16 pixels, it would take up 1 unit in world space. So for example, these different blocks, like the brick here, is a 16 by 16 image, 16 by 16 pixel image. And so when we bring that into our world, it's going to take up exactly 1 unit. Mario, for example, in his small self is also a 16 by 16 image. And so when Mario is in the world, he will take up 1 unit. But then when he's in his bigger version, he's twice the height. So his height will actually be 2 units. And this will just keep everything relative in size. And then also we can make sure everything sort of aligns to a grid in a sense. So this pixels per unit might just depend on your particular assets if you do create your own custom assets. And I definitely would encourage, if you want to use your own sprites, feel free. I definitely encourage that. All right, also we want to change the mesh type from tight to full rect. This simply will allow us to tile some of these sprites, which will be really handy specifically for some of the blocks. We also want to change the filter mode to point, or really that's also just no filtering. And this is important for pixel graphics because if you start filtering the pixel graphics, you kind of lose that pixelated style. So since these are intentionally designed to be pixelated, we don't want the filtering to kind of smooth that out. So we're going to get rid of filtering. And finally, there's some settings at the bottom here that aren't as important. For example, max size. None of these images are very large. So I think in this case, the largest it could possibly be is 256 of these particular images. But don't even necessarily need to change this. I do, however, want to change the compression because I noticed for some of these assets that once I pull them into the project, they start to look a little bit, I don't know, they start to have a little bit of visual bugs just due to the compression. So I'm going to actually get rid of compression. And since all of these images are super small, you know, a lot of them 16 by 16, they're very tiny images. We don't really need to worry about them taking up that much space. That's maybe one of the reasons why you would want to compress your images, is to reduce how much space they take up, because a lot of textures can be very, very large in size. But in this case, not a problem. So let's get rid of compression. That'll make sure they maintain their perfect quality, or the original quality of the image. And that's really all we need to do for our sprites. All right, next up, let's create some prefabs using these new sprites we've imported. And I'll explain exactly what a prefab is once we actually create one. But let's start with our background elements. So let's drag each of these sprites into our scene. We can start with bush 1, just drag it into the left. Here is our hierarchy. This lists all the game objects that exist in our scene. So when we did that, it created a new game object, it added a sprite renderer component, and it assigned that sprite to it. So let's go ahead and do that for each of these. Drag these in. Cloud 1, 2, 3, bush 1, 2, 3, and then hill 1 and 2. Those are our background elements. And for each of these, let's select all of these. We don't need to add any additional components to these, but I do want to change the sorting layer. Since these are background elements, I want to make sure they're always in the background, so we can add a new sorting layer. Let's click the plus button. Let's call this background. Let's make sure we drag this to be the first one. So we're going to rearrange that to be first, so that it's going to draw those first. Then it'll draw our default, which we'll put the rest of our objects on. And like I said, we don't need to add any other components to this. We just need the sprite render. We don't need any colliders or anything like that. Since these are all background elements, you're not able to interact with them in any way. So we're good there. Now we can actually turn these into prefabs. But first, let me create a folder for our prefabs so we can keep everything organized. So by us simply selecting one of these game objects and dragging it into our project panel, it will create a prefab for that. So what that is a prefabricated game object. It's essentially a game object that's been turned into an asset, and now we can reuse this asset across our entire project and across different scenes. Or we can spawn it in programmatically if we need to. There's all kinds of uses now that this has been turned into a game object. So let's do that for all of these. Let's just simply drag them each into the project panel here. And once we've done that, we no longer need them in our scene, because now they're assets that we can reuse over and over again. So we can delete those, and we just have these assets at our disposal when we need them. And that you can drag them into your project, or into your scene, I mean. You can have multiple instances of them, of course. And the nice thing about a prefab is if I change some of the settings or properties of the prefab, it's going to apply that change to all of them. So let's say on cloud 3 here, I change like the color to be red. Notice how those two instances of cloud 3 have changed. So that's the kind of the power of our prefabs there. So that's really all we need to do for our background elements for now. All right, next up, let's create prefabs for all of our blocks. Let's go to our sprites folder and let's bring in each of the blocks in our scenes. Let's add in our brick here. Let's drag that in, our empty block, our ground block, our hard block, and let's see what else. Our mystery block, and also the underground ones. So underground block, underground brick. I think that's all of them. So for each of these, we do need to make a couple other changes compared to how we did our background elements. These are objects you can actually interact with. Most importantly, we need collision on these objects. So to do that, we need to add a collider to our to each of these as a component. So add a collider component. A collider will define the size and shape of that collision area, the collision bounds of the object. So we can add component here, and you can search for collider, or in my case, I have a box collider here. It's a box collider 2D. There are other kinds of colliders, just different shapes. Once again, there's a circle collider, there's a capsule collider, but in this case, these are very blocky. So let's use a box. So box collider 2D. There will be a little green outline around them, assuming you have your gizmos turned on. It might be a little hard to see, but if we change the size here, you can see it better. So once again, this is defining the collision area or bounds of this object. Now we'll just keep these at size 1, 1, since it'll perfectly match those elements. And I did add this. I selected all the objects and added that because we want this on all of them. And that's really it. Although actually one more thing, we do want to change the order in layer 2. So our background elements are all on their own layer. Everything else we can keep on the default layer, but we do need to determine a priority kind of numbering for each of them. For our, for Mario, for enemies, for the blocks, we need to figure out which should render first. So I wrote up a little list here. 0, let's say, is our background. 1 will be power-ups, 2 enemies, 3 is Mario, 4 is pipes, and finally blocks will actually be last. So blocks will get rendered last on top of everything. Really, the only important ones here are Mario and pipes. We need the pipes to always be rendered on top, because when we eventually animate Mario entering into a pipe, it won't look right. It won't make sense at all if Mario is rendered on top of the pipes. We need the pipes to be rendered on top of Mario, because we're going to animate the position of Mario to sort of go behind the pipe, which will make it look like Mario's entering into the pipe. So if the pipes are not rendered on top of Mario, it won't look right. For the rest, it doesn't really matter as much, but this is the order that I've kind of found works best. So with that in mind, we'll set the order in layer to 5 for all of our blocks here that we have selected. And that's it in terms of these. We can drag these into our scene now, or into our prefabs folder. Let's drag those in. It creates a prefab for each of them, and that looks good. So we can delete them from our scene now, and then we're good. All right, next up, let's create a prefab for our pipes. Now this process will be a little bit different. So let's go to our sprites folder and find our pipes. Let's start with just the top and bottom. So let's drag each of those into our scene. So this one, there's 2 different game objects, or 2 different sprites. That way there's more flexibility of how you can kind of form your pipes. You can form them in different ways. You can make them horizontal, vertical, so on. So you have 2 different sprites, one for the very top of the pipe and one for the bottom. Now we need to create an empty game object in our hierarchy. So let's right click and go to create empty. I'm going to call this pipe. I'm going to reset the transform. Let's make sure the transform is reset so it's at the origin. And let's take those 2 objects we originally dragged in and drag those over pipe, and they should become parented to the pipe. So these are now children of pipe. We've essentially created a grouping. And I'm going to rename these 2 for more clarity. So we'll just call that top and we'll call this bottom. Now for each of both our top and bottom, we need to change the order and layer based on that same list. So once again, pipes will be at 4. And these are the ones that are actually important. So let's make sure we set those to 4. We want to make the pivot points of our pipe to be the very top of it, or where you basically enter into the pipe. So we'll keep that we'll keep the top one where it's at, but we need to move the bottom one below it. Now we do want this to be tileable in the y-axis, because some pipes will stick out of the ground much further than others. So let's change the draw mode to tiled, and now we can make this as tall as we want it to be. I'm going to set the height to be, let's say 12. This will give us plenty of space to work with. So we can have some really tall pipes if we want to. And we're good there. Let's make sure that lines up perfectly with the top. So this should be some even number, or I guess not a whole number necessarily, but in this case, -6.5 lines it up perfectly with the top. And now for both the top and bottom, we do need a collider. So let's add a box collider 2D. Now notice how the top one looks good, that matches, but this one doesn't. That's because we tiled the bottom and we need to change the size to match. So if you ever tile something, we should also update the box collider to be that exact same size. So there we go, we got both of those lined up and that looks good. So that is our pipe with our colliders, got our sprite renderers, and we're going to take the grouping as a whole, this parent element, and we're going to drag that into our prefabs folder. And so now we have this one complete game object, which is a collection of other game objects. We can now delete that from our scene. Now from here, we'll basically do the same thing for this pipe connection. This will be used for the underground section of World 1, or 1-1 is the level that I'm going to be designing. Let's bring in our pipe connection. We also want to bring in our pipe bottom so we can extend it here. Now for this one, or let's do that same process. Let's create an empty object. I'm going to call this pipe connection. I'm going to reset the transform so it's at the origin. Let's take those other two and parent them to that empty one. I'm going to rename this, let's say, to connector, and maybe to tunnel, just to make it a little bit more clear. Let's set the order and layer to 4 on both of our sprite renderers. And let's add box colliders to these as well. Okay, now for this one, we want the position to be relative to the, once again, the entrance point. So we want to offset the children to be relative, like, so the entrance point is at the origin. Let's move this here and there, so this looks like 2.5, and now the entrance point is perfectly at, let me get this other one out of the way. So the entrance point is perfectly where it's actually positioned. And now for our tunnel, this will be up here to make this longer. So let's tile this just like we did for the other one. And let's set the heights. On the other one, we set the height to be 12, but there is already one unit of kind of pipe sticking up here. So maybe we do 11 for this one. And then let's position it correctly. So 3, 7.5 lines it up perfectly. Let's make sure we adjust the size of the collider to match the size of this, the tiled sprite. So that looks good. Now the collider on this part here, it doesn't really match very well because it's just simply a box, and this is kind of a, you know, more of a unique shape. So what we can do is actually have 2 separate colliders, and we can kind of break this out into two parts. So we can do a little 2x2 here as one collider. So let's do that. So let's make this a 2x2. Let's offset these position here. So -1, -0.5. So we have just this little 2x2 part for one collider. We can add another collider to the same object, and this will be for the rest of it over here. So this is a 2x3. So let's make this 2x3, and let's offset it so it lines up. And so that looks way better, where now we have 2 separate colliders, but we're kind of shaping it to the, you know, the unique shape of this particular sprite a little bit better. So that looks, it'll be more accurate in terms of the collision. So that looks great. And I think we're all good. Let's just go ahead and bring this into our prefabs folder, just like we did for the other ones. So let's drag the parent object into our folder, and now we have our pipe connection. And finally, we can delete that from our scene. Okay, next up, let's create a prefab for our flagpole. So let's drag in the different flag sprites. So we've got the flag itself, we've got the pole, and at the bottom of the flagpole is always a hard block. But we don't want to bring in a hard block sprite because we already have a hard block prefab that has all the right components and settings on it. Let's bring in our hard block prefab. Now for our flagpole, it'll be very similar to the process we did with our pipes, where we need to create an empty object, and I'll call this flagpole. And let's reset the transform so it's at the origin. Let's take those other 3 elements and drag them onto our empty flagpole game objects so they become parented to it. And for clarity, I'm going to rename these to just be flagpole and block. Now we want to offset these objects such that the position of our flagpole is relative to the bottom of it. So the block here, that is the bottom. So the block is actually at the correct position at the origin. We need to take the other two and move these up. And so for the pole, it looks like it'll be 5.5 to line it up perfectly. And then for the flag, we'll bring this up to 9 and offset it to the left by half a unit. That looks good. So now once again, when we select our parent game object, the position of it is relative to the bottom of it, which is what we want. The only other thing we probably need to do here is change the order and layer of the flag so it goes on top of the pole. I guess it doesn't really matter too much, so if you prefer it the other way, feel free to keep it, but that looks good. We don't need to change anything on the block because it already has all the right settings since we're using the prefab. We do need to add colliders, but we don't actually need like physical colliders for this. We need a trigger collider so we can know when Mario has touched the flagpole, and then we can trigger the final animation sequence. So we can actually add a collider to the parent game object here. And I'm going to make this a box collider 2D, but I'm going to mark it as a trigger. And I'm going to update the size and position of this to basically match the whole thing. Let's say 10. Yeah, 10 looks good. And we'll offset this a little bit more, so 5.5. And it probably doesn't need to be that wide, so we'll maybe do a quarter. Yeah, that looks good. So it's basically just the pole itself, but this is what we'll use to determine when Mario touches the flagpole to then trigger the final animation sequence. Make sure it's marked as a trigger. All right, from here, I think that's good with our flagpole. We can go ahead and drag this into our prefabs folder, and then we can delete it from our scene. All right, lastly, let's create a prefab for our castle. So let's bring our castle into our scene. We're going to do the same process where we create an empty game object. I'm going to name this castle. I'm going to reset the transform so it's at the origin. And I'm going to drag in the object that has our sprite render as a child to our empty game object. Now it's maybe a little confusing because they're both called castle. So let's rename the child here to just be maybe sprite. So the parent is the empty one and the sprite one has the actual sprite render. And you might be wondering, why are we doing this since there's only one object in this case? Well, it's because we still want to change, we still want to reposition this so the position is relative to the bottom of it. So that's where, by having this parent-child relationship, we can offset the child element. So we'll bring this up, let's say, I think 2 units. Yeah, so now when we select the parent castle game object, it's positioned relative to the bottom here. That looks good. Now the reason we've been doing this, let me pull in our flagpole to demonstrate. So let's say our flagpole is in our scene at -6, 0.5, right? Our castle, if we give it that same y-axis values, 0.5, they line up. Despite them being different heights, they line up. So it just makes it easy to know like where to place objects in our level if we're following a grid, because these two are on the same kind of plane as one another. They're at the same elevation as one another. So that's why we do that. It just makes it easier later on. We don't have to do that, but I find it to be helpful. Now for our sprite, we don't need to change anything. The order and layer is good how it is. In a way, this sort of is a background element because everything else would always render on top. If Mario walks by, if an enemy, if a power-up, they're all going to get rendered on top. So we want to make sure the order and layer of this is 0. Once again, sort of as a background element, and then everything else will render on top of it. Finally, we do want to add a box collider to this as well. But not for, we don't need collision on the castle as a whole because you will be able to walk over it. We just need a trigger collider on the doorway so we can detect when Mario has touched the doorway and then start loading the next level. So we'll mark this as a trigger, and in this case it's a 1x2. Let's offset it And there we go. So we've got a trigger in the doorway so we know when Mario has entered and we can load the next level. That's it for our castle, at least for now. So we can drag this into our prefabs folder, delete it from our scene. And at this point, I think we're ready to start designing our level. All right, so at this point, we have all of our different prefabs that we can start constructing our level with. Let me show you a few techniques to make our level design a little bit easier. So for some of these, like our blocks, for example, let's bring in our ground as an example. We could duplicate this over and over again and kind of have these side by side to form our ground, but we don't need to do that. We can actually change our sprite renderer on this to be tileable, so we can kind of make one big ground all at once. In fact, we probably should have done that when we first created the prefabs, but it's okay, we can do it now. So let's select all of our blocks. I think any of our blocks has the potential to be tileable, whereas the rest of the elements don't really need to be tiled. But for all of these blocks, let's select these and let's change the draw mode to tiled. That's it. Now, when we bring them into our scene, so once again, I'll use the ground as an example, we can tile this by the width and, we can set the heights. That way we can form one big ground piece without having to place each individual block. Now, if you do this, if you do change the tiling size here, we're going to make sure we change the collider to match. So it should be the exact same numbers. That way the collision lines up. So there we go. That looks good. That's just an example. I'm going to actually go through and place everything at the correct positions. So speaking of which, if you're recreating an existing level from the original game, it's actually really helpful to take that level and break it down into a grid, and then you can use those coordinates to know exactly where to place them in the scene. So for example, let me bring up a reference image I found online. So this here is a reference image that I found online that takes 1, and overlays a grid on it, and you can see the coordinates. Let's say we wanted to place this mystery block right here. Well, we can see, okay, the coordinates are 8, 16. We can literally enter that. We can bring this into our scene, literally enter that as the coordinates, and now we know it's at the right position. And we can go follow that same process for everything to make sure everything's exactly how it lined up to the original game. Now, of course, you don't have to do that. And the great thing about this is you can fully make your own levels. You can make your own awesome, creative, custom levels using these prefabs, which is really neat. The levels can be anything you want them to be. Now, the only problem with this reference image I showed you is it's sort of flipped the wrong way on the y-axis. In Unity, 0 would be at the bottom here, and it would go up, whereas this is opposite. So this image itself won't actually be helpful necessarily. I'm going to try to include a reference image on the GitHub project that is my own version of this that has the coordinates kind of the right way based on how Unity handles it. So with that in mind, I think we can go ahead and get started and just start forming our level. Alright, so I've finished designing stage 1-1. I've even renamed the scene to reflect that. We've got everything here. I've just gone and used all of our prefabs that we created, placed them into the scene, and set their coordinates using that reference image. We, of course, don't have absolutely everything. For example, we're missing the enemies, but we're going to add all of those later on their own, so that will be in its own video. We even do have the underground section of the level here, once again using some of the prefabs we created earlier. For the background though, that's a little bit of a unique piece. All I did is create an empty square sprite, or sort of a blank square sprite, which you can actually do directly in Unity. So you can right click, create 2D sprites, and then there's square here, or there's other shapes as well. And I went and I assigned that to a sprite render, just set the color to be black, and then just of course scaled it to kind of fill the whole area. I did kind of neatly organize all the different things in their own little groups here, although that's not necessarily required. It just kind of helps keep things organized. But yeah, there's our whole level. However, we're not quite done. There's still a couple small things we have left to do. So for our camera, we still need to frame it in the right position and change the background color to be our sky color. So this white outline here is what the camera is seeing. So if we select our camera, we can, for example, change the size, and you can see how that changes. In a way, that's actually essentially zooming in or out. So for us, we actually want to increase this from 5 to 7, and 7 will give us exactly enough space to kind of fit everything within the frame. Obviously, you can customize this if you want to, but 7 gives us, I think it was like 16 units. It'll be able to fit within frame, which is exactly kind of perfect. Now we do need, of course, move the camera, kind of offset this a little bit. So now that we've kind of zoomed it out a little bit, let's get the ground to be at the very bottom here. So let's bring this up and line that up. So 6.5, we'll line it up perfectly, and let's shift it over to the right. Let's set this to maybe be 11. That looks good. Mario's going to spawn right here on this hill. And so that all looks good. You can, of course, change which aspect ratio you're previewing the game in. 16:9 is pretty standard in this case. All right, so finally, we just need to change the background color here. So let me get the hexadecimal for this. Of course, you can feel free to use your own, but if you want to use the same sky blue that I'll be using, which is based on the original game, 5C9 4FC, and that all looks great. That's all we need to do with our camera. We can pan this over to kind of simulate the side scrolling and kind of just take a look at everything. Everything kind of is in frame. It all looks good. Got our whole level there. So that all looks perfect. We can, of course, look at the underground section too, which I think is right below us. Yep, so that is all good. Awesome. So our camera's set up, and from here, the next steps are to actually start implementing the mechanics of the game. So now that we have our level built out, we can do that. We have kind of enough to work with to implement a lot of the mechanics. So in the next video, we're going to focus on Mario and his movement and physics and all that. So it's going to be a lot of fun. So stay tuned for that. I really appreciate you watching this tutorial, and I hope you learned a thing or two along the way. Give the video a thumbs up or down to let me know how I did. Subscribe to the channel to know when the next video in this series is released, as well as any of my other tutorials. If you want to support my work even more, you can become a Patreon member to receive exclusive benefits, including early access to the rest of this video series. Link in the description of the video. Thank you for watching. See you in the next one.